All right. So we're up and running. Does someone want to begin with a question? Practice test 6B. All right. Practice test 6B. Okay, Garrett. So there's the test from the book. So we can move that over a little bit. And 6B says, in triangle ABC, the measure of angle A equals the measure of angle B, which equals 2 times the measure of angle C. So, let's get my pen going here. So we're told that A equals B, and that equals 2 times angle C. So, we want to put this in terms of, let's see, how can I think of this? So, A equals B, A equals 2C. And we want to find the measures of the 3 angles. Okay, so now the 3 angles add up to 180 degrees because they're the measures of triangles. Okay, so A plus B, which is the same as A, plus C, which is, let me explain. So if we take this, here, let me move this further to the right. So if we shove this over even further, I mean, if you take this part right here and expand to the right, A equals 2C, and divide both sides by C, you would see that C is A over 2. So when you add up the 3 angles, you get 180 degrees. So, I don't know, 2.5 A equals 180. 5 halves A equals 180. And then you can get rid of that 5 halves by multiplying both sides by 2/5. And we've got A, because these all cancel, A equals 360 over 5. And 360 over 5 is 72 degrees. So We're not quite done yet. Let me make a little space. Whoops. Sorry, I gotta get on there and do my eraser thing. All right, now let's go back. Pen, and let's go back to the hand. We'll shove this all up. And so now we've got A, and we know that A and B are the same. So A equals 72. B equals 72. And C equals half of that. If we add the 3 up, we really do get 180 degrees. So that's number 6B. I don't know. Hopefully you can all see that. Amy asked, can you look at 8.4, 17 or 19? Yes. Okay, so let's go back. Shove that back there. And let's go back to 8.4. Well, I might not have that in here. That would be an 8.3. So let me just quick open that up. Okay. Real-time board. Let's go get 8.3. All right. 17 or 19? Oh, I'm sorry. I'm looking in the wrong place. I should be looking right here in 8.5. 8.4, 17 or 19? Sorry, a little bit out of kilter here. Okay, so here's number 17. Now, on that problem, I got to get my book back there. 8.5, number 17. The edge, 8.5, number 17. The edge of the base of a square pyramid is 4 inches. It doesn't look like I have the right one, do I? All right, how about number 19? Oh yeah, I'm in the, I was okay with 17. Okay, I'm on the wrong page. All right, I got a teacher who can't find the right page. Here we go. A rectangle has a diagonal 17 feet long and a length of 15 feet. So the length of the side, how wide is it? So wide, W, length 15, and diagonal 17. So do you notice that right here is a right triangle? So we can use the Pythagorean theorem. One leg, W squared, plus the other leg, 15 squared, equals the hypotenuse, 17 squared. 15 squared is 225, 17 squared is 289. Subtract 225 from both sides and we get W squared equals 64. And now we take the square root. W equals 8 feet. We can look at number 19 too. Make sure you've got that. Number 19. Yeah, and you were right. Either one, they're similar. In this one, the base of an isosceles triangle is 16 inches. So you see the 16 down there on the bottom. And the equal sides are 17 inches long. The other two sides are isosceles, so 17 are equal. Find the height of the triangle, that is the perpendicular distance from the base to the opposite vertex. So in an isosceles triangle, the height, what, bisects the base? So these two sides are equal. So therefore, this side down here is 8, and now we look at this little right triangle over here on the right. And here it is simplified up here at the top right. Again, use the Pythagorean theorem. One leg h squared plus the other leg 8 squared equals the hypotenuse 17 squared. 8 squared is 64. 17 squared is 289. Subtract 64 from both sides, 225. Take the square root, 15 inches. So the height is 15 inches. Garrett, did you get your answer, your question answered for 6B on the test? Oh, okay. Sometimes I lose. I have too many places to look. I've got one screen, then I've got the other screen, and then I've got that column for group chat. I don't always keep a close eye on that. Thank you, Amy, for the questions. Uh, 8.5, number 5. You bet. Well, we don't have that one here, so we'll stick that one in. Okay, 8.5, number 5. So let me get my pen. (8.5), number 5. All right, let me get there. Number 5. Make a sketch. Oh, a triangular pyramid. Yeah. So we've got a triangle for the base. And then they come up and they, well, I missed by a little bit, but that would be a triangular pyramid. Hi, Paul.
Hello.
So that's it. Number 5, I think all they wanted you to do was make a sketch. So yeah, it's a little bit crazy with three-dimensional things to try to draw them on two-dimensional paper, but that would be how you do that one. Number 9, if the edges, oh yeah, okay. Thank you for asking number 9. Okay, so 8.5, number 9. Whoop. Okay, well, we'll just put up with that stray mark there. All right. So, if you've got a cube, let's see. So first of all, this idea that when you've got a cube and each edge is 1, and then you double the edges, it's 2 cubed, or 8. So when you jump up 2 dimensions from length past area to volume, you're jumping up 2 dimensions. Then the ratio gets, instead of a 2-to-1, it's 2 cubed to 1 cubed, which is 8-to-1. So that's the answer to the first part. Let me get my pen. So that's the answer to the first part. And the second part, what happens if the lengths are tripled? If the original lengths are 3 to 1, now those become 3 cubed to 1 cubed. And so the final answer is 3 cubed is 27. 3 times 3 times 3. Can we look at 8.5, number 5, or number 7? Okay, I think that's what. Did I do that already? Let's see, 8.5, number 5, or number 7? Okay, here's 8.5, number 7. Yeah, 8.5, number 7. A 6-sided polyhedron that is convex and not a parallelepiped. So the idea here is that, thanks, Paul. You just shared your notebook with me. A parallelepiped, I don't want you to have to remember that, but a parallelepiped is where all the sides are parallel. And here I'm trying to show that, the sides taper in. So that's what number 7 is. Number 5, oh yeah, 5 I already did, a triangular pyramid. Okay. Trying to keep up with the chat room here. Eight, 6, number 3. All right. Okay, we don't have that one, so let's just do it. So 8.6, number 3. So first of all, 8.6, number 3. Okay, so let's try making that a little bit neater. So we've got this network that looks like this. So, and the question is, find the number of even vertices, the number of odd vertices, tell me whether it's traversable or not. Okay, so odd vertices, so now you do a count at each vertex. How many line segments come? So that one counts 1. B has 2 that come to it. E has 1, 2, 3, 4. C has 3, and D has 2. How many odd vertices are there? 2 of them, 1 and 3. How many even vertices are there? 3 of them, 2, 4, and 2. Is this traversable? Yes, because if you have no odds or 2 odds, it's traversable, right? Isn't that what the rule states? If you, here, let me, yeah, it's up on the top of page 566. A network with no odd vertices is traversable. A network with exactly 2 is traversable. So 0 or 2. And so this one is, yes, traversable.
Are you looking for another one?
You bet, anytime.
Okay. Chapter 8, or lesson 8.7, 12 and 13, the last two problems, which really started with number 11. And as I read through number 11, which, references number 10, and I looked at the answer in the back at number 11 because I couldn't figure out how to even, or the answer I came up for 11 wasn't what was drawn in the back. And they all tie together, 12 and 13. So I was just stumped. So I don't know if it's better to start with 11, then go to 12, or
Yeah, and I've got, let's see, we'll take a look at that. 8.7. Okay, let's move that to the side. Okay, so 8.7, start with a square developed by fractal replaced in problem number 10, but with the small square drawn inside the larger square. Let's see.
so I kind of took that as that approach you were drawing in one of your examples, where you were doing the indented square.
Number 10. Okay. And number 10, so number 10, oh my, 11 goes back to 10, doesn't it? Yeah. Okay, 10, start with a square, developing a fractal. Okay. So, you start with a square, develop a fractal by replacing each side. All right. So, okay, so we start with a square. Okay. And replace each side as in number 10 with a small square drawn inside the larger square. So what we've got then is we take the eraser and oh, that's not going to work. Okay. I just remembered with this thing I can't do that. So anyway, what happens is this goes like this.
Yep.
And then over here, this side goes away and is replaced by and then down in the bottom, that side is replaced by very crudely drawn here, sorry. And then we get rid of that and we replace that. Okay, so we've done it one time.
Mm-hmm.
So what area remains after the first step? Assume the original square to be side S. So from here to here was side S, right?
Okay.
So we're down to what? 2/3? Okay, so So what do we got for an area? So the original original area is S squared, S by S. You know, with this being S down here.
Yep.
Okay. So now with this one, what we've got here is 1, 2, 3, 4, 5 ninths. Because each of these squares is the same size, even though it doesn't look like that. So after the first iteration, wow. Okay. After first iteration, 5 ninths S squared. Okay.
Oh,
So that's
okay.
number 12.
Because we've
So in other
subtracted
words,
4 out of the.
you got 1, 2, you got 1, 2, 3, 4, 5 out of the original 9 left. Okay. And then number 13 says, all right, what happens when you do it again?
So
Well,
you're
when you
making
do
a
it
smaller
again,
version.
each one of these would look like the big. And basically, it's being multiplied by 5 ninths again. So it's going to be, it's going to be 5 ninths squared,
Mm-hmm.
which is 25/81st after the second iteration.
You make it look so easy.
Well, I don't know, that's pretty sloppy, but anyway, that's the idea of that one.
Yeah, and I see in Garrett's comments he was saying use a 3x3 to. Yeah, that makes sense.
Yeah.
Good. That's all I had.
Okay, cool. Yeah, yeah. Those are difficult to convey. With words, those are difficult problems to state. So I'll be honest, those are hard, and for a multiple choice question, that's going to be a real stinker to try to come up with one like that. But anyway, that's what that's about.
Well, great. Well, I have an appointment I need to head out to, so that was my only question. We still got. You're going to open the test up tomorrow.
Yep, I've got it set up like before. Friday morning at 5 in the morning, going to Saturday night. Yeah, just like before, it's open for 2 days, Friday morning through Saturday night.
Sounds good. Well, and then you said you may have that chat on or the Moodle chat room on Monday night just to check in after the test.
I think so. Yeah, so everybody, let me announce that right now. Week 10, I'm still going to have the chat on Monday night. I think that'll probably be the last activity we have, but I mean, by then the course will be done. But if you want to check in, I should. I mean, if everybody gets their stuff in on time, I should be able to have everything graded by Monday night. So,
well, sounds good. Good luck, Garrett and Amy and everybody else. Thanks again, Professor, for all your help. Appreciate it.
welcome, Paul. Have a good evening.
Yep. Bye-bye.
Bye. Good night, Amy. Yep, just you and me again. You got it right. Garrett, I just remember just a comment. I just remember I think it was the first evening we got together, and I remember, boy, you had a raft of questions, and I remember you being what, real nervous. I would say nervous about the whole thing. Anyway, it's really cool to see how well you did and how that worked, how that worked positively for you. So that was good news. Practice test number 14. You got it. Okay, practice test. Let's see, I got to find it. Here we go. Practice test. Okay, number 14. Okay, let's see if we can make this bigger. Stick it over there on the side. All right, number 14. So let's get my pen. A window is in the shape of a rectangle surmounted by a semicircle. So a window and a semicircle on the top like that. The width of the window is 3 feet, which is also the diameter of the circle. Yeah. So from here to here, 3 feet. And the height of the rectangular part is 4 feet. Okay, that might solve it right there. Find the total area of the window. So we have what? The area of the semicircle and the area. That's not going to work. Semicircle and square both starts with an S. Okay, let me come up with something a little different. The area of the top and the area of the bottom. There, that's real elegant. The area of the top is pi r squared over 2 because it's not a circle, it's half of a circle. And the area of the bottom, well, that's just, the side squared. So the area of the top, pi times 3/2 squared over 2, right? Because 3/2, in other words, it's half of 3, 1.5. So when you square that, you get 9/4 pi over 2, which is 9/8 pi. And the area of the bottom, well, that's just 4 times 4, 16. So what's the area of the whole thing? That would be 16 plus 9/8 pi. And did they give us a label? Feet. So that's square feet. Gotcha, Garrett. I see. Yeah, sometimes half the problem is interpreting the problem. In the case, yeah, in a case like this, I think I might give you the drawing of the square with the semicircle on top of it. Um, I don't know. Yeah, I probably would give you a drawing, and then you wouldn't. Yeah, then you wouldn't be just like they did here down on number 18. Put a sketch right in there. So I think I might stick a sketch in there like that. By the way, Garrett, on the practice test, you probably, I don't know if you notice this, but there's, I gotta find it. I'm on the wrong page as usual. But 22 and 25, um, yeah, they really should be X'd out. And they're 25 is not worded very well. I mean, let's put it this way: 25 is still ambiguous, and 22 I wouldn't ask you. So didn't get a chance to tell everybody else that. But. Yeah. Should you have the Excel spreadsheet up? Um, um, I don't think that. Uh, I I can't remember, but I don't think. No, let me think here. I do have a problem on the test that does iteration, but I only ask you for the third iteration. So what I can't remember is the formula exactly the same. So I don't know. It wouldn't hurt to have it handy, but be careful that that equation that's used in there. Let's see, where do we have one of those in here? That would be no. Oh yeah, right here. That number 24, 2x times x minus 1. I think my formula this time is 1 minus x. So I don't know if it probably won't help. So, but I'm only asking you to do three iterations. So you can just take a calculator and whack it out. Yeah, I think the problem is that x minus 1, I think on the test might be 1 minus x. I can't remember. Yeah, anyway, be careful of the order, okay? Look for the order. And so, you can have the spreadsheet handy, but if it's not the same formula that's at the top of the spreadsheet, then you can't use it. And just whack it out. Yeah. Well, I hope what yeah. I think you guys, I think this is turning out pretty well. I like the way, what I originally envisioned was somebody could do, I make you guys do a lot of work in your notebooks. And I think that's the way to learn. And that has really worked well because I'm really pleased with the notebooks. Um, so already I feel pretty good about the overall results. And the notebook counts pretty heavily. So, like with you getting a perfect grade on it, really sets you up nicely. So, yeah, I know you put in the hours. I can really tell. I looked at your notebook and I thought, boy, this guy did. That's what I hoped a student would do. And now you're right. That took a lot of time, but I don't know. There's no other way to really get in and learn mathematics than to kind of roll up your sleeves and get in there. So it's cool because students get in there and do the work. They can. It's amazing what people can do. And by the way, the extra time, the fact that you and I are often on here alone together says a lot about you two. Uh, that's pretty cool. So, Garrett, does that, so I know we're jumping the gun here a little bit, but does that mean that um, you're going to be graduating in December? Are you going to be in the graduation service? No. Oh, that's right. You already graduated. Otherwise, I was going to say, I get to meet you, but I guess that's not the case. So, anyway, yeah, I'd like to meet you too. Anyway, God bless you. And I'm really happy that you got your degree at Wisconsin Lutheran College. Yep. See you on Monday, Garrett. Have a good evening.